So let us understand what iterators and generators are in Python. So before we even proceeding, let's first understand what iteration is. So what is iteration? Okay, so let's assume we have a sequence of numbers. So let's say we have some numbers 1, 2, 3 and 4. Okay, so this is a list of numbers. So iteration is basically all about navigating through each and every item that is present in a sequence. So iteration is basically all about navigating through all the items which are present in our sequence. And iterators are basically the sequences which can be iterated, right? So for example, this particular list can be called as an iterator, right? So list can also be called as iterator, but list has additional features like indexing, slicing, and even some of the built-in functions. So even tuple is also an iterator, and even strings can be iterators, right? Because they are also sequences with which you can write for loops on these types. So that is why we can call them as iterators. So let us try to write a for loop on list. So let's define a list here by writing 1, 2, 3 and 4. Okay, so I told list is an iterator because we can loop through all the items inside the list, right? So I can write a for loop on list. For I in lst1, I can simply write print I, right? So yeah, an iterator can be anything which has a minimum feature of iterating through each of its elements. So if a sequence has a minimum feature of iterating through all the items inside it, then it can be called as an iterator. So yeah, of course list is an iterator, but along with the basic feature, it has other features like indexing, slicing, and as I discussed, various built-in functions which are available exclusively for the list data type. So in Python, if you want to create an iterator, okay, if you want to create an iterator object which has this basic functionality of iterating through all of its elements, so we have a built-in function called iter. So using this keyword, you can generate an iterator, or you can create an iterator. So let's try creating an iterator object using this iter keyword. So I'll say iter1 equal to, so this is the name of the iterator that I am going to give. So iter1 is equal to so using this keyword iter, I will pass a list of numbers. Okay, so I want to convert this list of numbers into an iterator object using this iter keyword. So let me execute this, okay, and check the type of the iter1. Okay, so we can see that it is an iterator, or more specifically, it is a list iterator object. Okay, so now you can write a for loop on the iterator to navigate through different elements, because as I already said, iterator has the basic feature of you can write a for loop, or you can loop through all the items inside the iterator. So for I in iter1, I can write this for loop and simply print for I in iter1. So I'll write print I, right? So but let's try to understand how this for loop, so how does this for loop actually works under hood, or how this for loop can be implemented, right? So let me define this iterator object again. Okay, so there's a built-in function in Python called next. Okay, it's called as next. So basically what it does is it will fetch and return one element at a time from an iterator object. Okay, so when I say the next of iter1, it is going to fetch the first element of our iterator object. What is the first element of our iterator object? It is 1. So this next of iter1 is going to give us 1, right? So if you execute this again, what do you think will be the result? So it's going to fetch the next item, which is 2, right? So it's going to give 2. So if we just repeat that, it's going to give 3, right? So what if I let's use next function again and see what happens, because we know that our iterator object has only 3 elements inside it. So what if we try fetching the next item, which we know that it's not there? So let us see what is the result that it is going to give. So when we execute this, we get this exception called as stop iteration. So an exception of type stop iteration is thrown, which basically means that the iterator object is exhausted and there are no elements to fetch further. Okay, so now let's try writing the structure of for loop by making use of this next keyword and also this exception stop iteration. So we're just trying to create for loop, or we're just trying to understand how the for loop works under hood, right? So using this next and stop iteration function, we can loop through all the elements in our iterator object. So let me define this iterator object again. So iter1 equal to iter of numbers 1, 2 and 3. So I'll write this while loop, while true. So it's going to execute continuously until a given condition, right? What is that condition? The condition is that it should throw an exception and then it will stop iterating. So while true, you try and you should try printing the next item. I'll say next of iter1. So we're gonna continuously keep fetching each of the items from this iterator object, and then at one point of time we know that there will be an exception thrown which is of the type stop iteration, right? So when this exception is thrown, we will come out of the while loop and stop fetching the items. Okay, so when we execute this, we can see the result 1, 2, 3. This is just same the result that we will get once we write for loop. So for loop is so simple, right? So this is basically equivalent of for loop. Okay, so now you must understand how elegant and easy it is to use for loop on the iterable objects in Python. Okay, so that's about iterators. Now let's understand what generators are in Python. Okay, so generators are basically a type of iterator. So it is also a type of iterator. So it looks just like a function. So if you don't know how to write a function, is like this is how you write a function. You write function which accepts 2 parameters, for example a and b, and then it is having a return value. I'm going to return some function. I'll write some function. So it's going to accept 2 parameters and it's going to return the sum of the 2 elements. So this is how a function looks like. What I'm trying to say is the generators also looks similar to function, but instead of having this return type, you can define your iterators, or the elements that you want to have in your iterators. Okay, so you can basically add elements into your into our list or iterators using this keyword called as yield. Okay, so let's try creating this generator. Okay, so I'll write def generator 1, 2, 3. Okay, so it doesn't have any input. so it doesn't have any return. So as I already told, it has something called yield keyword, using which you can add elements to this generator. So I'll add 1, 2 and 3. So in this generator I have 3 values, 1, 2 and 3. Okay, so I'll execute this. Now let's call this function and check what is the type of what is the type that it's going to return. So I'll simply print the type of generator 1, 2, 3 and if I execute, we can see that it is of the type generator. It is not a function, it is a generator. So now let's create a generator, okay, using this generator function or generator. I'll call this, and when I execute this, we can see that a generator has been created. Okay, so as I already told, the generators are just like iterators, which means that we can use the next function on the generators just like iterators, right? So you can write next of generator 1. What is it is going to give? It is going to give the first element, which is 1. Okay, and then if you use it again, it will give you 2. Use it again, you gives 3, and if you want to use it again, it works exactly like the iterators. You'll get an exception stop iteration. Okay, you can write a for loop on the generator. So let me define the generator again, and I'll say for I in generator 1, I'll simply print I. So this will also work on the generators. The for loop will also work on the generators. Okay, so that's about iterators and generators in Python.